Hello, now welcome to my channel again. So today we want to show you how to download the Landsat imagery book from Google Earth Engine, and also we want to show you the two ways. Now there is a if you use the code for downloading alone, you can come across clouds on your satellite imagery, which you don't want to work with. It's not good to work with satellite imagery with clouds. But you can mask out the cloud. You can take out the clouds and mask your imagery so that you don't have you have no clouds or minimum clouds on it. Using the same satellite imagery of the same year that you have. So right now, let me jump into it. Let's just give the two examples. So the first one is we are going to run the code with cloud and the one without cloud. So let's see this. All right. So we are looking at our ROI from assets. This is looking at Lagos. That's Lagos State from Nigeria. So we say our importing Lagos. If you have your shape, it's a shape file anyway. And if you have a shape file, you can just use this arrow to import it. It comes as a table, but you are the one to change it to what you like. So for me, I like to put it as ROI. So we have this. Now we are collecting, that's our region of interest, that's our area of interest anyway. So here we are looking at to collect Landsat 8 data imagery, collection 2, Landsat 8 collection 2. We are using the satellite imagery for our data, and this 8, Landsat 8 collection 2, tier 1, L2. So this is the data we are looking at. So we can copy these and let's look at it. Let's copy. If you want to check, let's see the characteristics of the data. Okay, this is it. So let's look at it. So this is the Landsat 8 level 2 collection 2 tier 1. So this is it. It started collecting the data in 2013. That's 2013. That's 18th of March 2013. That's the day it started collecting the data. This is the description of the imagery. These are the bands that it has: B1, B2. B3, B4, B5, B6, B7, and the horizontal, the data that you have your imagery to band 7. This is the attributes anyway. So you have and it tells you the description. This is the name. This is the description. This is the minimum value, the maximum value, and the wavelength of each band. So, but here we are going to use the band 432, which is for our composite. So this is the data. This is the Landsat imagery that we are working with. So we close that. There is it. Now we are looking at the date. It's a dot filter. That's VR collection, image collection. You call out your Landsat imagery here. Then dot filter date. You want to look at the date. You can check from any date. Remember it started from 2013, so that means you can get data from 2013 to recently. So here we are looking at 2021 data. We want to filter date. We want to look at 2021 data. So there's they say define the date range for 2021. Now we are looking at 1st of January 2021. And between 1st of January, we want our data to be collected between 1st of January 2021 and 31st of December 2021. If you can remember, if you are trying to get your data from the Earth Explorer, USGS, the website, you define your date, your range too. So here too, you define your range. Now we are saying filter. Now here is a global data. We are calling on a global data here. Now here we decided, okay, we want these dates. We don't want just any date. We want this particular date. That's what we call filter dates. Here now we are looking at filter bound. We don't want all the global data of this Landsat 8. We just want our study area, and we say dot filter bounds ROI. Remember we called our Lagos State shapefile, we termed it as ROI here. So then if I change this one to let's say interest. If I change this to interest, let's see. You see, if I change it to interest, you see that the filter bounds also change to interest automatically. Any name I change it to, or any representative name I give it, the filter bounds also recognize it automatically. Well, let's take it back to ROI, because I prefer ROI. You can give it any name anyway, but I prefer ROI. So we have it. This is telling you the ID, telling you the version, the column, properties, and of these. I think we don't need it like this. Okay, we have it. So we called it ROI back. Here the filter bounds changes to ROI. So we say filter by ROI. We want to filter out this global data. We want to filter out for ROI, which is a Lagos State. Now we say cloud cover, sort by cloud cover ascending. We say sort cloud cover true. Here we say, okay, select the least cloud image, VAR image equals collection dot first. So we want to collect the least cloud image. That means the data, the Landsat data that have the least cloud image. We are trying to filter our image to the least cloud image, but we'll still see what we are going to have. Even the least cloud image still have clouds, much clouds on it. So let's go ahead and see what we have. They say apply necessary scaling factors. Now we are applying necessary scaling factors. We are looking at field optical bands, thermal bands, within the which we identified when we look at the activity. The characteristics of the Landsat imagery that we are using. Now this one say clip. Now we want to clip that our ROI. We want to clip this Lagos State house. So they say clip. That's dot clip ROI. Now this is the vis params, and that's the color. The minimum of 0, maximum of 0.03, gamma 1.4. Now here we are trying to say we want to center the object. We want our object to be at the center of the mapping interface within the Google Earth engine. Here we have United States, but for us to pan to Lagos State, it will be difficult. Rather, we want to do it automatically. We say map center object to ROI and at the scale of 10. Map center object ROI at the scale of 10. So here we now say we want to export. We want to export to drive. We want to export into our drive. Now here you say map add layer. Map.center object is different from map add layer. We want it to map the center to our study area. We want it to show it at the center of the mapping interface at a scale of 10. As well, here map.add layer simplifies that. We want the layer, our center object to show. If you don't put this code of map.add layer, we won't see it. Even it will go to where Lagos State is when we run it, but we won't see the data. Though the data is there, but it won't show it. So here we want, that's why we said map.add layer, so that it can add the layer so that we can visualize it. And the map add is what data is in mapping? Clipped image. And if you look at this, we say VAR clipped image. We call our clip ROI, our ROI that is clipped, we say we represent it as clipped image. And so that when you come here, you don't call your clip ROI again. You call the representative name, which is the clipped image, you call it out. Clipped image. And you don't just want the image to come alone. You want it to come with the colors, with colors. So you say, your color is your vis params. Then you say clip image, vis params. That means clip the image, show the color of, and name it as this Lagos State image, your result as this. Name your result as this. You can give this any name, but I decided to give it Lagos Landsat 8 image. Now here we want to export to our Google Drive. What image are you exporting? Is the clipped image, this image. What description? This is the description here. 2021 Landsat, Lagos Landsat image 2021. You can give it any name that you like. The scale is 30 because Landsat is a 30 meter, has 30 meter resolution. 30 meters, so you have the scale of 30. Region that you are looking at, your ROI. Then let's run and see what we have. Now see what we have. Even after here where we said select the least cloudy image, we said select. That means this is the least cloudy image that we can have. This is the least cloudy image that we can have. But yet, we still have much clouds on it. So how can we do? What can we do to remove these clouds? So that takes us to the this script. Okay, that takes us to this that I prepared the script already. That's image Landsat image without clouds. Now we have the same. Let me take this one away. I don't want. Let me represent it with shapefile. Delete. Represent it with shapefile. Set. Labels. Color. It's coming up. Comes out stable, change it to ROI so that it can tell you it's my okay. Now if you look at this, define our region of interest. We've defined it, that's our ROI. Now the first thing we have to do is cloud mask function to cloud mask. We have to use a cloud mask function for Landsat 8 collection 2. That's our satellite imagery, and this is the function. Function mask LHSR image. And VAR QA. This is the function. QA pixel. That was a cloud masking function. Now we are going to define our cloud mask shadow to 1 to 3, and our cloud vis mask to 1 to 5. Now both flags should be set to 0, indicating clear condition. So we have to set both. This is the standard of our cloud shadow and our cloud bit mask. But now we have to set them to 0. Both flags must be set to 0. So here we now say this, we call this out, we set it to 0. This, that's cloud shadow bit mask. We do, the function is var mask equals qa dot bits wise and open a bracket, call this out dot equal 0. Also call the cloud bit mask out and dot and qa, the same thing, bit wise and open a bracket, cloud bit mask dot equals 0. Then you say return image dot update mask. Now if this function runs, you are saying that if these two functions, if they runs, the image will return as update mask, which is mask. Once that function runs, once these two functions runs on the satellite imagery that you collected, that you were defining with that we define here, once these two functions runs, the image should come back as update mask, as mask. Then we call our Landsat 8 imagery. We call it out here. We run the same thing, filter dates, the same date we used in the first one. Then you now say filter bounds, our arrow high, which is our Lego state that we used in the first example. Then we say dot map mask Landsat 8 SR. That means we are applying this. We are applying this function, which we say we should return as this. Now we are calling this one in here, and we have apply. We said we are applying the cloud mask. This is the function of the cloud mask. Now we are applying it on this our satellite imagery within our arrow high region of interest. Then we say apply necessary scaling factor for collection 2. Function apply scale factor image. VR optical band. This is our optical band. This is our thermal band. Then return image. Optical band null, true. And band thermal band null, true. Now if we do this, if we run this function, we ask, or rather we say we ask the Google Earth engine to run this function for us, and if it is true, is then, but if the function cannot be executed, give us null. But if it can be executed, say run it as true. The same thing as this. Then we have a scaled VR scaled collection, which is equal to collection dot map apply scale factor. Apply scale factor. We say apply scale factor is this. This is apply function of apply scale factor. This is the function of apply scale factor. Now, if this run, then we call it out. We call this out. After this runs, after this finally runs, we call it out, and we call it out VAR scaled collection is equal to collection dot map apply scale factor. It's case sensitive, so it's better. The best way for you is to copy this out. Copy, highlight, copy, and paste it so that you don't run into any error of that is case sensitive. Now, create a cloud-free composite by taking the medium of the image collection. Now, you know we have in the data collection we said you should collect from 2021 that's January 1, 2021 to 31st December 2021. Now, we don't want all images for these days. We just want a kind of a kind of a single image. So we will now say let's run where is it? We now say run a composite. We want a composite imagery of 432, bands, and we say a composite image should be scaled collection dot median. That we want a single, we want a median data from 1st January 2021 to December 31st 2021. We want the median data, and this is a function for the median. That's the average or the median data. And we say clip. We still want to clip our ROI. We don't want all the data for that median data, but we want for our ROI. We say dot clip ROI. Now we run our data visualization parameters. The RGB band, band 4, band 3, and band 2. These are the bands we are using as our RDB for our RGB. The minimum of 0, maximum of 4.3, gamma 1.4. Then here we say add the composite image to the map. Map.center object ROI. This is our image ROI, and at the level of 10. Map.layer. Now this one, as I explained the other time, this one makes you to be able to visualize your data on the mapping interface, to help you to be able to visualize. Then you export it. That's image as composite, description Lagos. You can give it a name of your own choice. Scale is 30. Landsat imagery is in 30 meters. Sorry, and your region that you are interested in is your ROI. So let's run and see our product. Voila. Now you see our product. You see this imagery now that we have. You see it's different from the first one. This one is cloud free, and you have to understand that we are using the same year. We are considering the same year and the same satellite imagery. We consider the same year with the previous one. This year, January 1st, 2021, and December 31st, 2021, and we use the same Landsat imagery, but now we are having a cloud-free satellite imagery. Which one will come here to the task? The task is blinking already. We can run and download. You see the imagery we have now is different from the first one. This one is cloud free. Then we run it, and we once we run it, it downloads into our Google Drive, and we can copy it from there and use it in our GIS software for further analysis, maybe at GIS or QGIS and the likes. So that is the situation, and there's a function for removing the cloud from the satellite Landsat satellite imagery. So thank you for being with us in this lecture. We want you to like our page. We want you to subscribe to our page. And if you have any question, you can put it in the comment section of this video, and I'll be happy to reply. Thank you very much. See you soon.